So the current that flows through it is I2 phase. So losses here is 3I2 phase squared R1. Peak or loss, you don't have to calculate, but usually it will be given. Okay, if it's not given, then we can assume it's 0 lah. So PRCL, rotocouple loss, losses at your R2. So R2 is also R2 is somewhere at the end of the equivalent circuit. So the current that flows to R2 is I2 phase. So PRCL is equal to 3I2 phase squared times R2. Okay, and then mechanical loss, you won't be asked to calculate them. If it's there, it will be given. If not, you can assume it's 0. And same goes to stray loss. Stray loss, if it's given, then use it. If it's not, then you can ignore it. Okay, what else? Okay, PI gap. PI gap, okay. From the equivalent circuit, this is the air gap resistance. So current that flows through air gap is I2 phase as well. So we can say that the formula for air gap power equals to 3I2 phase squared times R2 over S. Okay, so for P air gap and P converted, we have another formula that is called induced torque times omega S. Why omega S? Because your air gap, the rotating is still the magnetic field. So we take the speed of the rotating magnetic field, omega S, because we are still in the input part. Okay, towards the end, then only we use omega M. Okay, and then for P converted, it is equal to induced torque also. Okay, times, but not times omega S. Okay, converted power equals to induced torque times omega M. Why? Because we have moved towards the output part, so the rotating part is the rotor, no longer the magnetic field, so we use omega M. So another formula for converted power is 1 minus S P air gap. Okay, and then PRCL has another formula as S P air gap. From if you are curious, from where do we have this formula? Okay, just compare the formula between PRCL and PI gap here. PI gap is 3I2 phase squared times R2 over S, while PRCL is 3I2 phase squared R2. So if we times S here with your PI gap, we can cancel out S, and we are only left with the formula PRCL. So that's why we can write a new formula. If we times S with PI gap, we will get PRCL. So P converted equals to PI gap minus PRCL. So factorize PI gap, you come up with this formula. PI gap times 1 over S equal to P converted. Okay, just now 100 watt minus 2 equals to 96 watt. So PI gap equal to 96 watt. So 96 watt minus 2, so P converted equals to 94 watt. So 94 watt minus 2 equals equal to 90 watt. Alright, so hope you can get the idea on how we read this power flow diagram. So in this slide, you can read through. Actually, it lists down the alternative name of those power in that power flow lah. For example, P converted is also called as converted power, developed power, or mechanical developed power. P converted, P dev, or P dev lah. Banyak nama. And then okay, stray loss. Stray loss, it's stated here that it is the loss that is not easily calculated, including harmonic losses in the core and current flow through the core. So the other name for P stray loss is P miscellaneous loss. I hope I pronounced it right. Okay. And then mechanical loss has two types, friction and windage. And then core loss, also called as iron loss. Please take note. And then what else? Okay. In terms of torque, we have at the output we have load torque. Load torque also called as output torque because it's at the output side. So output torque and load is always at the output side. So output torque equals to load torque. And then okay, induced torque from this formula is also called as air gap torque. Okay, because it comes from the formula air gap. So induced torque equals to air gap torque equals to developed torque as well. Okay, but be careful, P air gap equals to induced torque times omega s, while P converted equals to induced torque times omega m. Okay, so this is an additional info that you need to know. Sometimes the output power, that is mechanical power, is given in horsepower. Okay, the unit of output power, that is your mechanical power, is given in horsepower. So to start to do the calculation, you need to convert it into watt. So for example, if the output power is 10 HP, so it's actually equals to 10 times 746, that is 7460 watt. Okay. So last one, efficiency, very general, PR over P in times 100 equal to the efficiency. Okay, so that P out and P in, you should be able to get them from this power flow diagram. Okay, but take note that if you can calculate using the given formula here, do calculate. That is the first rule. Second rule, if you can't calculate it using the formula, for example, if R1 is not given, R2 is not given, and then what else? Usually if R1 and R2 is not given, then you can use the plus minus operation. Plus minus operation of the power flow. For example, if this is given as 2, 2, 2, 2, 2, so can you find, and this is 100, can you find P converted? Yes. You don't need to use this formula. You just like I've explained before, 100 minus 2 minus 2, you get P I get 90, 96, and then 96 minus 2, you get 94, and so on. Another thing is actually you can go from input to output or output to input. So this is just an additional information, but I would suggest students to only memorize one way, not two way. But if you are interested, you actually, for your information, we can start from the back. For example, P out just now 90 plus 2 just now plus 2 is equal to 94. 94 plus 2, P I get, you'll get 96. 96 plus 2, P I get plus P core, 98 plus P SCL, another 2 watt. Then you'll get your P in, that is 100 watt. So you can start from the front, from the input to output or output to input. But to avoid confusion, I suggest my students to just use one way, and then just write whatever equation you have. For example, P in minus P RCL minus P core equals to P I gap. Then P I gap minus P RCL equals to P converted, and then P converted minus P max minus P straight equal to P out. Then write down a mathematical equation. Then if you want to rearrange mathematically, you pindah right side to left side, minus become plus, plus become minus. That is just mathematics. Okay, no need to confuse yourself. Okay, that's all for the second video. Inshallah, in the next video I'll explain on the examples in the slide. There are 4 examples, but basically I'll just show 2 examples to represent Y connected, the difference between Y connected induction motor and delta connected induction motor. Okay, Alhamdulillah, thank you. See you in next. Before that, summary. Never mind, I'll explain this in the next video. Okay, that's all. See you in the third video. Thank you.